Hello everyone, how are you all? I hope you are doing well. I am Dr. Nandita and I would like to welcome all of you to Aptdemy. So today in this live session I am here with you to solve a numerical problem on the concept that you have learned in chemical thermodynamics. But before going into the problem, let me share some information with you. So this live session we are conducting almost on a regular basis. So you can check, and people who are not watching right now, you can go and check the playlist of Aptdemy. So you can get access to all the videos made by us. We teachers are here to help you on any based on your requirements, offline, online sessions, problem solving sessions, doubt clearing sessions. We are here to help you. And you can go and check our website www.aptdemy.com, get registered there, and after registration you will get 24/7 access to all the course materials that are already uploaded there. And so just don't waste time and get connected and get registered with Aptdemy. So now let's go into the problem. But before I start the problem, let me talk a little bit about the base of the problem. I have chosen a topic of combustion reaction that you have learned in chapter chemical thermodynamics. So what is actually combustion? So combustion is a kind of reaction where any fuel is getting oxidized in presence of any oxidizing agent and heat energy is evolved due to this reaction. So now let me give you some examples that you are observing around you almost every day. So first one is in any country where winter is the main season, you are burning coal or any wood. So it is an example of combustion reaction. Every day almost many cars and buses are running by burning diesel or petrol. This is also an important example of combustion reaction. You are cooking food by the help of burning LPG or natural gases. This is also an example of combustion reaction. So you can see that, you can imagine that how important combustion reactions are in our day-to-day life. Now, without delaying, let's get started with the problem. This problem appeared in Joint Entrance Advanced Examination 2022, and I am going to share or solve this problem with you based on many students' requirements, right? So what is the problem? The problem is 2 moles of Hg liquid is combusted in a fixed volume bomb calorimeter with excess of O2 at 298 Kelvin and 1 atmosphere into HGO solid. During the reaction, temperature increases from 298.0 Kelvin to 312.8 Kelvin. If heat capacity of the bomb calorimeter and enthalpy of formation of HCl liquid are 20.00 kJ per Kelvin and 61.32 kJ per mole at 298 Kelvin respectively, the calculated standard molar enthalpy of formation of HGO solid at 298 Kelvin is X kilojoule per mole. We have to find out the value of X. That is, we have to calculate the standard molar enthalpy of formation of HGO solid. Also, gas constant value R is given as 8.31 joule per Kelvin per mole. Now, with the given information, let's see how can we solve the problem. So, before we start, or we can just start by writing down the combustion reaction. So, the reaction is 2Hg liquid plus O2 gas is giving you 2 moles of HGO solid. This is the basic combustion reaction. What other information are given? We have initial concentration, initial temperature of the calorimeter, which is 298 Kelvin, and also the final temperature is given as 312.8 Kelvin. So So from that, we can easily calculate the change in temperature, which is delta T. That is 312.8 K minus 298 K, and this is giving you 14.8 Kelvin. So this is the change in temperature due to this combustion reaction, right? And also we know heat energy which is evolved during this reaction can be written in the following form, that is Q is equal to C times delta T. C is nothing but your heat capacity of the calorimeter, which is given as 20.00 kilojoule per Kelvin. So 20.00 kilojoule per Kelvin is your heat capacity of the bomb calorimeter, and delta T we have calculated as 14.8 Kelvin. So this Kelvin will cancel out and you end up with 296 kilojoule. If you calculate, you will get 296 kilojoule as the heat evolved. So as the volume is fixed for this reaction, what can we write? That internal energy, which is in the form of heat of reaction, is your minus 296 kilojoule because your volume is fixed. Also, this heat of reaction or enthalpy of reaction can be related to delta UR0 by the following equation. That is, delta E0R is equal to delta E0R plus delta NGRT, where this is your enthalpy of reaction, this is your heat energy, which we have calculated as minus 296 kilojoule, and this delta Ng is the change in the number of gaseous moles during the reaction or combustion reaction. So we have to calculate from the equation. How can we do that? In the product side, we don't have any gaseous molecules, only 2 moles of solid H2O has been formed. So here we have go with 0. No gaseous molecules, so 0. Minus in the reactant side, we are always using a minus sign for the reactants. So we have 2 moles of Ag liquid and 1 mole of gas. So for here we can use minus 1, right? Because we have only 1 mole of O2. So this is giving you minus 1, right? Now we know the value of minus 296, which is for delta U0R, and delta Ng has come out as minus 1 per mole, and R value, that is the gas constant value, has been given as 8.31 joule Kelvin inverse mole inverse. This is our value of gas constant R, and T is given as the absolute temperature, that is 298 Kelvin. Now if you solve, this is in kilojoule we have calculated here, and if you solve this part, rest of the part, you will get minus 7.42, and your delta HR0, if you calculate, will come out as minus 303.42 kilojoule. So this is the value we need to keep in mind. Rest of the part I will do in the next slide. So minus 303.42 kilojoule has come out for the value of delta H R0, which is the heat of the reaction. So let's move on to the next slide. So what we have calculated, I'm just writing down, delta A0 reaction has come out as minus 303.42 kilojoule, right? Now, the heat of the reaction can also be written. I think I have to go back again because I have to go back because, or maybe I can do the rest of the part over here because I have to use the values which I will not find in the next slide. So delta H R0 was come out as minus 303.42 kilojoule, right? Now, delta H R0 or heat of the reaction can also be written in the form of the heat of formation of products and reactants as well. So let's write down the equation again. The combustion reaction 2Hg liquid plus O2 gas is giving you 2HGO solid. Yeah. So yeah. Now this can be written in the following form. So because we have 2 moles of solid HGO in the product side, so we will multiply our 2 for this and we will write delta HF, that is the formation of HGO gas, solid. This is the heat of formation of HGO solid, and because 2 moles of product has been formed, so we are multiplying with the 2 for this. And for the reactant side, the heat of formation must be negative, so we will use negative sign for the reactants, right? Again, we have 2 moles of Hg in liquid state, so delta HF, sorry, here 20 will be there because it is formation. Standard heat of formation for HGO solid, this one, and I'm now writing for the reactants. So 2 moles of Hg liquid. So this is the heat of formation for Hg liquid, and 2 moles has been used to this multiplied. And another one is O2, another reactant. So 1 mole of O2 was used for this reaction. So delta, the heat of formation for O2, it would be minus delta HF0 O2 gas. This can be the reaction enthalpy can also be written in the following form, right? Now, this we have to calculate. So 2 times delta HF0 HGO solid we have to calculate, and we have calculated it previously as minus 303.42 kJ, and other part will go as class on that side. And we also know that because oxygen is in its standard form, so formation delta HF0O2 must be 0. So we will only have to use the value of this. So this will come out as plus 2 moles of delta HF0 Hg liquid, which has been given as 61.32 kilojoule per mole. So 2 times 61.32 kilojoule per mole is giving you minus 303.42 plus, we have to multiply with 2. So this is giving you 64, 122.64. Now, if you subtract it, you'll get 180.78, right? So this is for 2 moles of delta HF0 AgO solid, right? So delta HF0 AgO solid is equal to minus 180.78 divided by 2, which is giving you minus 90.39 kilojoule per mole. And this has been asked to calculate in this problem, right? That is the molar enthalpy of formation of HgO solid. So this is our answer, that delta HF0 HgO solid, that is molar enthalpy or heat of formation of HgO solid, has come out as minus 90.39 kilojoule per mole. So this is what has been asked in this problem. Very simple, you just need to remember the formulas, or based on the information which are given, you have to fit into the formulas and easily you can be able to solve the problem. Very simple. I hope you have enjoyed this live session. So what are you waiting for? Get connected and get registered with Aptdemy. Thank you very much. Our live session will be conducted on a regular basis, so get connected with us. Thank you very much for listening carefully, and I will see you soon. Thank you. Bye-bye.
এটা কি এক্সোথার্মিক রিঅ্যাকশন এন্ডোথার্মিক?